Okay, so in this video, I just want to outline a summary of Chapter 8 and just review the basic steps of doing a hypothesis test. So we've looked at hypothesis tests earlier this semester, and we're not going to change too much about it except in step 3 when we find the p-value. So when we're setting up a hypothesis test, just recall the setting that we would use a hypothesis test for is when we have a claim that we want to test about the value of a population parameter. And so here we're not necessarily trying to give an estimate or an interval estimate for that value, but someone claims a value about that parameter, and we want to test to see whether that claim seems likely to be true. So the first step is to state the hypotheses. And at this point, you would want to consider whether or not you've got a one or two-tailed test. So the same rules are going to apply for stating our hypotheses. We want to use population parameters when we state our hypotheses. We want to make sure that the null hypothesis has inequality in it, and the alternative hypothesis should have an inequality in it. And so if we have a greater than sign in the alternative or a less than sign in the alternative, then it's a one-tailed test. And if we have a not equal to sign in the alternative hypothesis, that would be a two-tailed test. So these are some ideas that we've thought about earlier. Next, we would calculate a test statistic. And this test statistic is going to be a measurement of how extreme, one way to measure at least, how extreme is the sample that we gathered compared to the claim in the null hypothesis. And so typically we might think about this as measuring how many standard errors was the observed value that we got from the value that's claimed in the null hypothesis. And the goal here when we're doing a hypothesis test is we hope that we can prove the null hypothesis is untrue, and therefore the converse of that, the alternative hypothesis, is true. So what we hope to get here is we hope to find evidence that our observed sample is far from the null claim. And once we've got that test statistic, then we can calculate what's called the p-value of that observed sample. And the p-value is going to be it's a conditional probability. So given that the null hypothesis is true, what's the probability of randomly getting a sample as or more extreme than the one that we observed? So that's how we can think about the p-value. And visually, the p-value we can think of as the area in either one or both of the tails beyond the test statistic. And now a new part of this process that we haven't talked about so far is this step 3. So in step 4, which is using this significance level. And we'll talk about this significance level in more detail, like what does it represent and why would we want to set different values for this significance level. But for now, let's just think about the significance level is representing the benchmark for how extreme does our sample need to be. So if our p-value is less than the significance level, then in that situation, we can reject the null hypothesis. So we hope that we're in this boat over here. If our p-value, however, is greater than the significance level, then we do not reject the null hypothesis. And so in that case, that's an unhappy face there. Okay, but that would tell us that our result is not statistically significant. And then we want to be able to summarize these results to maybe a more general audience. So you wouldn't want to just say the p-value is this and therefore we rejected the null hypothesis, but you would want to be able to take your conclusion and be able to explain it in practical terms to, say, a non-statistician. So one way that you can summarize the results is in the case when you reject the null hypothesis, then this in fact does give us evidence to claim that the alternative hypothesis is likely true. And in the event when we do not reject the null hypothesis, just be sure that this does not mean we can conclusively say that the null hypothesis is true, or that we conclusively say the alternative hypothesis is not true. When we cannot reject the null hypothesis, we just say that the test is inconclusive, and we leave it there. Okay, so let's just walk through some examples and highlight all of these steps. I think the best way to get familiar with the steps is just try and do as many different examples for hypothesis tests. So these sets of notes here, we're just going to take a look at how we can do hypothesis tests on a single population. So we're going to do a test on a single mean and tests on single proportions. And then next week we'll move on and think about how we can do hypothesis tests when we're comparing two different populations.